Hello everyone, I want to take you through a review of what we've talked about so far with radians and then show how it applies to the unit circle. Now, in class we have a blank unit circle like this with all these different spots that we have to fill out. Today we're just going to talk about the angle measures in radians. So as we do that, you can fill it out on your paper, and then later on we'll talk about how to do the rest of filling out the tangent, sine, and cosine on the unit circle. So just a very brief review of what a radian is. If we look at the radius of a circle here, and we were to cut that out and start wrapping it around the circle, what we refer to as 1 radian is actually measuring the angle in reference to the radius wrapped around the circle. See, when we talk about degrees, we're talking about a rotation of the terminal ray right here. Here we're talking about, instead of a rotation, we're talking about wrapping the radius around the circle. So somewhere in here is 1 radian. Let's see if I can make this a little bit larger so you can see it. So let's take this. There's 1 radian. Somewhere in there, it's just an estimate. I don't really have it calculated out just yet. There would be 2 radians if we wrap 2 radii around the circle, and then 3 would be just a little bit shy of halfway around the circle. Continuing on, we'd get 4, and then 5, and then 6. Like I said, this isn't the scale, but 6 would be just a little bit shy. In fact, we would find out that it's about 0.28 shy, 0.28 of a radius, so it should really be about 1/3 of a radius shy of a full circle. And that should make sense because we've talked about before the circumference of a circle is pi times the radius times 2. So, or 2 pi r. And so 2 pi r is the same thing as pi times the diameter. Or you could say, what's 2 times pi? Well, 2 times pi is about 3.28 times the radius. That's how many times, not 3.28, 6.28 times the radius. That's how many times you should be able to wrap the radius around. 1, 2, 3, 4, 5, 6, and then about 0.28. That should be that, maybe a little bit further down right there. About 0.28 of a radius left over going through that. We did an activity in class where we cut out a wire and we wrapped it around to see how many times that wire would go around if the wire equaled the length of the radius. So in essence, 1 radian would be somewhere around in here, and it'd be if I took this radius and made the arc length right here of this chord, not the chord, this arc getting cut off, if that arc length was equal to 1 radius, that is 1 radian angle measure there. So that's a quick recap. In class I explained it a little bit slower, but we've gone a while since we've talked about them, so I wanted to just kind of review that. Now, the other problem we come into here is we typically don't use, this angle right here is not a common angle that shows up. So a lot of times our measurements just don't come out to be 1 radian or 2 radians or 3 radians. If you think about degrees, common degrees that we use, or common angle measures we use that are in degrees, are things like 30-degree angles, 60-degree angles, 90, 45, 180, 360. These are things that come up naturally in our shapes, whether it be a rectangle with 90-degree angles, an equilateral triangle with 60-degree angles. A lot of times the hexagon will have 120-degree angles in it if it's a regular hexagon. And of course, halves of 90 is 45, half of 60 is 30, a full circle is 360, a triangle's angles add up to 180. Those degree measures show up commonly in our shapes that we come across. And so they're going to come across commonly again when we talk about measuring angles in radians. So we have to find a way to relate degrees and radians because these angles are common. So let's erase this. And let's just start by looking at a typical circle. And we say if we go a full circle, then we've gone 360 degrees, if we're speaking in degrees. But in radians, unfortunately, it's not an even 6 radians. It's actually about 6.28 radians, or to be more specific, you can fit, if you take 2 times pi times the radius, you'll get a full circle here. So we say it's 2 pi radians. So let's erase this, and that kind of gives us our first fact. So when we do something like we're trying to construct the unit circle on our own, we're going to say, okay, if I go a full circle, then I've gone 2 pi radians. So this is 2 pi radians right there. Now, that's starting from right here and going all the way around to right here. 2 pi radians. That's the equivalent of 360 degrees there. But what if I only go half of that? So if I go halfway around the circle, I've gone half of 2 pi. So if we think about it as taking 2 pi times 1/2, just make this 2 pi a fraction, I get 2 pi over 2, or pi radians. So this right here, this goes with this angle right here, that's going to be pi radians if I go halfway around the circle. Now, what if I go half of that? So if I let this right here be one whole, half of that would land me right here, our equivalent of 90 degrees, but I'm going halfway to pi. So if I take pi times 1/2, I get pi times 1 is pi, and 1 times 2 is 2. I get pi over 2. So this measure from here to here is the same as pi over 2 radians. Now, from there, that allows me to find out this other angle down below in between quadrant 3 and 4. So if I look at this as 90 degrees, if we think about degrees for a moment, I could go around and count in 90-degree segments. So this would be 190 degrees, this would be 290 degrees, or 180. This would be 390 degrees, or this angle is 270 degrees. And this would be going all the way around the circle 490 degrees, or the equivalent to 360 degrees. That's if I were to count these things out in degrees, 90 degrees at a time. And so I don't want to do that. I'm actually going to do it in radians now, so we can figure out this angle down below in radians. So instead of saying 90 degrees is this section, I can say it's pi over 2, because pi over 2 radians is the same thing as 90 degrees. So this is 1 pi over 2. This would be 2 pi over 2 right here. And notice these 2's cancel and you get pi. And then coming down here, this would be 3 pi over 2. And if I kept counting, I'd get 4 pi over 2 right here. And 4 pi over 2 reduces to 2 pi. So that allows me, to figure out this other angle down below. And so what I've just done is I've said, okay, what are the angles right here? By the way, we could call this 0 radians if we're just at the start. 360 degrees, or 2 pi radians if we go all the way around the circle. But I'm drawing lines, trying to draw a line at where I just found these angle measures. Now if it helps you, you can switch colors. I've got a lot to choose from. I'll do light blue next. And the next thing I'm going to do is look at what we call our 30-degree equivalent right here. So in degrees, this is 1/3 of 90. This is 2/3, or 60 degrees here, and then this is a full 90. So you take this 90 degrees, divide it by 3 to get the 30 degrees, times that 30 by 2 to get the 60 degrees. And so that's our degree equivalence there, but I want to know what it is in radians. So in radians, we start at pi over 2. And how we came up with the 30 degrees, we said 90 degrees, 1/3 of that gives me 30 here. So now I'm going to take, instead of 90 degrees, I'm going to say pi over 2 times 1/3, because this section is 1/3 of pi over 2. And that gives me pi over 6. So this angle becomes pi over 6. Now as I look at this, I'm going to jump 30 degrees from here to here, from here to here, from here to here, from here to here. I'm going to go ahead and highlight this one right here, blue. This one's going to be blue. That's another 30-degree increment. 30 degrees here, 30 degrees here. another 30, another 30, another 30, another 30. So notice I'm really just skipping over this line I haven't colored yet. And so you could go around the circle if you're talking about degrees and count out in 30 degrees. Here's 30, 60, 90, 120, 150, 180, was it 210, 240, 270, 300, 330, 360. That's if you're counting in degrees. But instead of counting by 30-degree segments, I'm going to count by pi over 6 segments. That way I can figure them all out in radians. So this is 1 pi over 6, 2 pi over 6. Stop at every blue line here, including the dark blue. This is 3 pi over 6. This is 4 pi over 6. We're going to skip this one. This is 5 pi over 6. This is 6 pi over 6, 7 pi over 6. This is 8 pi over 6. This is 9 pi over 6 right here. We're going to erase that in just a second. This one is 10 pi over 6. And then 11 pi over 6. And then 12 pi over 6. Now I meant to put this one right in here, which is, what do we got? 5 pi over 6, 6 pi over 6. So there's a lot of pi over 6s in there. Once again, we skipped over these because they're not multiples of pi over 6. So I do want you to reduce these, but as we go through, you should just be counting 1, 2, 3 pi over 6 right here, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, 12 pi over 6. And then reduce. And so as we reduce, the 2 pi over 6, that's going to become pi over 3. The 3 pi over 6 reduces to pi over 2. And I've already got that written there, but it's just like my checkpoint to make sure I didn't skip over a line. 4 pi over 6, that reduces to 2 pi over 3. 5 pi over 6 does not reduce. 6 pi over 6, the 6's cancel, I get just pi. My checkpoint checks out. I'm just going to erase that for room later on. The 7 pi over 6 does not reduce. The 8 pi over 6 reduces to 4 pi over 3. The 9 pi over 6 reduces to 3 pi over 2, so my checkpoint works out there. 10 pi over 6 reduces to 5 pi over 3. 11 pi over 6 doesn't reduce. 12 pi over 6 reduces to just 2 pi, so my checkpoint works there as well. So all in all, this gives us all of our 30-degree multiples equivalents, or you could say pi over 6 equivalents. And so that is a big chunk of the unit circle taken out. Let's do those black lines now. I'm going to just color them in red so they stand out a little bit. Now, these red lines right here in degrees are 45 degrees, or multiples of 45 if you count the red and the dark blue. So you know from here to here is 90 degrees. So this red line right here would be 45 degrees if you're talking degrees, or 90 times 1/2. So to figure out its equivalent in radians, we're going to take that pi over 2 and let me get rid of that red line there. That pi over 2, that's this angle right here, this one, and we're going to times it by 1/2, and that gives us pi over 4. So that's this angle right here is pi over 4. Now it's kind of hard for me to put all this data in, so just got to keep in mind that this line right here goes with this mess and so forth through here. So once again, we could go around and count in angles, say this is 1 pi over 4. Well, actually, before I talk about before I talk about radians, let me talk about degrees. You could say that this is 45 degrees, plus 45 make 90, plus another 45 make 135, plus another 45 makes 180, and so forth. But we're going to learn this in radians, so let's count in radians. So this is 1 pi over 4. Skip over the light blue. That's not a multiple of pi over 4, but land right here because it is. This is 1 pi over 4. This would be 2 pi over 4. That's our checkpoint. 3 pi over 4 right here. This is 4 pi over 4 right here. That's a checkpoint. This is 5 pi over 4. 6 pi over 4 right here, that's another checkpoint. 7 pi over 4 right here. And then 8 pi over 4, that's a checkpoint right there. So this is, we'll count them out again, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, come down to right here, this is 5 pi over 4, 6 pi over 4, 7 pi over 4, and then 8 pi over 4. So after you got that written out, we're going to reduce. 2 pi over 4 reduces to pi over 2, so that checks out. 3 pi over 4 doesn't reduce. 4 pi over 4, the 4's cancel. It's the same thing as pi. 5 pi over 4 does not reduce. 6 pi over 4 will reduce to 3 pi over 2. So that checks out. 7 pi over 4 doesn't reduce. 8 pi over 4 reduces to 2 pi. So that's our angles on the unit circle that we commonly use, and those are listed in radians. I want you to not memorize the unit circle. I want you to go through and understand why the angles work the way they do, why certain coordinates that we'll learn later on are sine and certain ones are cosine, and how we come up with the tangents of those angles. Because I think if you understand it, you'll remember it for years to come, or you'll be able to construct it if you don't remember it on a test or a quiz in here. But if you just try memorizing it, not only are you lacking that understanding for future math, but it's going to be harder to come up with later on. Now, there might be some things that you just got to flat out memorize, but as you study this, there are ways to study it without just memorizing. Like take 5 pi over 6, for instance. If you remember that this line right here is 5 pi over 6, you could say, well, I know that half a circle is pi. And if I take pi and I subtract from it just 1 pi over 6. See how this right here, it's like the 30-degree equivalent? 1 pi over 6. If I subtract that from pi, how do I do that? Well, I need to make this a fraction, so put it over 1, and then you would say this is the same thing as 6 pi over 6. Notice the 6's cancel, giving you pi. If I say 6 pi over 6 minus pi over 6, I get 5 pi over 6. And so that's another way you can look at it. You know, if you take 3 pi over 4, if you don't know that, but you know that this is subtracting pi over 4 from pi, you can say, hey, 4 pi over 4, it's the same thing as pi, minus 1 pi over 4, it's the same thing as, in degrees, 45 degrees, gives you 3 pi over 4. So you start to see those tricks and patterns the more and more you use the unit circle. My goal for you today is to be able to take out one of these blank pieces of paper, with the unit circle drawn on it, all blanks, and fill out all the angles. Even if you have to count them out and then reduce them like I do, I'm giving you, I think, a paper with, I don't know, it's either 8 or 12 unit circles like this on it. I think it's 8. You know, do one with the video if you want, do one without the video, then check it, and then wait a little while and, you know, try it later tonight or early tomorrow morning and just keep practicing. If you want blank ones to do later on to practice it, do that. But learn the angles first. We'll talk about the points later on because I want you to be able to start visualizing. When I say pi over 6, I want you to be able to visualize this angle right in here. Okay? So that's the goal there, and hopefully this makes sense to you. And we're getting ready to talk about the next topic, which is switching from radians to degrees and degrees to radians. So when we convert from radians to degrees or degrees to radians, it's important to note that a full circle is 2 pi, as we discussed a few minutes ago. So half a circle is pi radians, or the same thing as, if we're talking about degrees, 180 degrees. So we can say this is our main conversion factor that's usually used. 180 degrees is equal to pi radians. And so I usually write these out as fractions. If I've got 180 degrees divided by 180 degrees, that would be the same thing as 1. Or we could say that if I had pi radians divided by pi radians, that's the same thing as 1. And why do I go through the trouble of saying all that? Well, if this is true, then I can substitute the denominator out right here with pi radians. And so let's go ahead and do that. And also, if this is true up here, I can substitute the denominator over here with 180 degrees. And they're both equal to 1, which is nice because we don't want to change values when we convert. So let's suppose we had something that we didn't know, like 30 degrees, because that's a common angle in our unit circle. We could say convert that to radians. You could use these conversion factors. You could say, you know what, I'm going to take 30 degrees and multiply it by the number 1. That way I don't change the value, but I'm not going to multiply it looking at it like this. I'm going to multiply it so that the degrees cancel. I'm left with radians. So if I make 30 degrees a fraction, I want to pick one of these two fractions, either this one right here or this one right here, and multiply 30 degrees by it so that degrees will cancel. Notice, since 30 degrees is in the numerator, I need to pick the fraction with degrees in the denominator. So if I put pi radians over 180 degrees right here, the degrees will cancel out, and I'll get 30 pi radians over 180 degrees. And now I just need to reduce this thing down. So notice 30 over 180 is, oh, the degrees canceled, didn't it? 30 pi radians over 180. The 30 over 180 becomes 1/6. So you end up with 1 pi radian over 6. Or we just say pi over 6 radians. And remember, we just did the unit circle. This 30 degrees is pi over 6. Now, I don't want you using this to come up with the common angles. I want you to do the method I showed you at the beginning of the video. But this is a great way of coming up with angles. You know, let's say you are in crunch time and you need to come up with just a simple one. You can do that. Or if you've got just some weird angles that are not common ones, you can use it for that. So let's suppose we had, I don't know, 35 degrees. Once again, put it over 1. I want the one that cancels out degrees. So I'm looking for one with degree in the denominator. That's the one on the right here. So we multiply it by pi radians over 180 degrees. And then the degrees will cancel, and I'm left with 35 over 180 times pi radians. And I know these will both can be divided by 5. So let's see, this would be 7 pi over the radian here. If this were divided by 10, it'd be 18, but it's being divided by something half as much, so that would be 36. So 7 pi over 36 radians is what we're dealing with there. So that is going from, these last two examples, we're going from degrees to radians. But we can also go from radians to degrees. So let's pick one we know, like pi over 2. We know that's 90 degrees, but let's see how we can use it doing this method. It's already a fraction, and I'm going to multiply it by 1 in this format right here. So I'm going to multiply it by 180 degrees over pi radians. A lot of times we don't write it, but there are units up in the top here of radians. So notice the radians will cancel, so will the pi, and I'm left with 180 degrees over 2, which equals 90 degrees. If it was something like, I don't know, say we had 3 pi radians, and I wanted to convert that into degrees. Well, make it a fraction. Pick the fraction up here, equivalent to 1 with radians in the bottom, so the radians will cancel. That's going to be the one on the left, 180 degrees over pi radians. The radians again cancel, so does the pi. 3 times 180 is what? 360 plus 180, which is 540. And then you still got the degrees there, so it's 540 degrees there. All right, so that's how you switch back and forth, and I've got 2 worksheets there for you to try out. I think they're a little fun, just going through those mazes there to find degrees to radians and radians to degrees. Give you a little extra practice, because the more comfortable you become with the 2, I mean, most of you are comfortable with degrees, but the more you become comfortable with radians, the better you're going to do in the future in this class and future classes. All right. Thanks for watching. Let me know if this video helped, and have a good day.